morning, UK. How are we doing? How are we doing?
Great.
Okay, good. So welcome to our talk about writing your own ticket to the cloud like APT. And we are here my name is Dr. Nestori Sunima, and I work for SecureWorks, and I'm the Senior Principal Security Researcher. And I have another talker here.
Yeah, my name is Roberto Rodriguez. I'm a Principal Security Researcher at Microsoft, and I'm part of the Microsoft Security Research Organization. And I collaborate a lot with this guy, so now I have to see him in conferences too and talk to him.
Yeah. So let's start with a quote that kind of our presentation is based on. So we think there's John Lambert, he's a great guy from Microsoft. He said that defenders think in lists and attackers think in graphs. And as long as this is true, the bad guys are going to win. And this is kind of how we built our presentation. So this is based on the talk I gave earlier this year in Troopers in Germany. I think it was June or something. And it was called 8 Ways to Compromise ADFS. But in this talk, there's not going to be any new attack vectors or anything like that, so sorry about that. So it's more like defending. But anyways, here's what we're going to talk about. So short introduction. Then we're going to introduce you ADFS attack and defense graphs. And finally, we're going to wrap up that how you can protect against golden SAML attacks. And few concepts first. So, well, we have a user, right? And then we have a service provider. And I'm talking about identity federation concepts. So not that federation that we covered with keynotes. So that's a totally different one. But anyways, we have service provider, which in this case is Azure AD. And user wants to access that service. We have identity provider, which in this case is ADFS. And the ADFS is trusting the user. When the user provides some kind of proof of identity, then the ADFS trusts that. And also the Azure AD is trusting the identity provider. But how can we prove that, who the user is? So here comes the technical part. So we have security token. In this case, it's called SAML, or Security Assertion Markup Language token, which is signed by the ADFS. And then when the user is accessing Azure AD, it is trusting that ticket. And that's how the user can prove who he or she is. And one slide about golden SAML attack. So that's how I think it is. So it is using 2 MITRE techniques. So first we're going to steal certificates, and then with those certificates we are going to create, or we're going to forge SAML tokens. So in order for this to work, you need to have the token signing certificate from that identity provider, regardless what it is. And in this case, we are going to focus the first one. So how can we steal that certificate? So there are different ways to do that. And now I'm going here because I want to get the numbers right. So is it this important? So how many of you is using ADFS or any other federation? Quite few,
quite.
Yeah? And probably the rest of you are just lying or you don't know that. So a little statistics. So from last year, about a year ago, from Fortune 500 organizations, 88% was using Azure AD, and from those, 68 was using Federation. And about 6 months ago, from top UK 60 organizations, 86 was using Azure AD, and from those, 60% has at least one or more federated domains. So this is still a thing, right? And here's the ADFS attack list. Quite easy. You start, you export stuff, and you're good to go. And I think it was 4 years ago when Doug Bienstock introduced the ADFS dump. That was tool, yes. Mm-hmm. And if you protected your environment using that, it's not enough. So there's more to this. So let's start with some ADFS details. So first of all, for token signing certificates, you have 2 options. So you can have them managed, which is the default one. And then that certificate is stored in a configuration database. And it is encrypted using a key that is stored in AD. So you have 2 ingredients. And the second option is to use custom certificates, which means that they are just normal certificates which are stored in the certificate store of each ADFS server. So you have these 2 options. And now this attack graph is going to look more like graph, right? So we have a couple of options, and we need to cover all of those. But it's not that easy. There's more. So you can store, you have a couple of options for storing that configuration. And the first one is Windows Internal Database, or WID. I think it's also known as SQL Express at some point of time. But anyways, in this configuration, one of those ADFS servers is a primary node, and the others are secondary nodes, right? And each of those servers have their own copy of that data in that database. However, if you try to make like configuration changes, only primary node can do that. So the secondary nodes are synchronizing the data from the primary node. I think it was like once in 5 minutes or so. So there's a service that allows you to pool the configuration, okay? And the second option is to use MicroSQL servers to store that data, which means that there's no primary nodes anymore, or secondary nodes, because every single server can connect to that centralized SQL server. However, that service that allows you to synchronize the configuration is still there. So now that we have the graph, so we have different ways to store data. There's different ways that we can use certificates, and this is the whole stuff. And now we're going to go through each of these steps. So I'm going to tell how you can compromise those, and then my friend Roberto is going to tell you how you can detect that and maybe even mitigate or prevent that, right?
Some of that, yeah.
So let's see. Let's start with the access configuration database. And that was the part of the original ADFS dump. And we're going to start with local. So we can see here's local. And we have a couple of different methods. And by local, I mean that you need to compromise that ADFS server. And now the access configuration database, it simply means that when you have compromised that computer, you're accessing the database, which is usually like that local database. So how can we detect that?
So one of the things that is very important from a defense perspective is to be able to understand that there is a couple specific things that are happening under the hood, and you have to be able to describe all those little things so that you can start mapping things such as data sources, mitigations, detections, etc. And I think that that's the part where the graph comes into place, because graph is not only to talk about identities, how they connect to each other, how they have access to certain things. We can actually apply those concepts to when we want to build detections in general, right? So in this presentation, we're going to cover the concepts of operations, things that are executed by a tool, right, used by a threat actor. Artifacts are going to be things that are going to be created, things that are going to be used as part of the execution. And then also we're going to talk about data sources and also some mitigations later on. So when we talk about accessing the configuration database, right, there's going to be two specific actions that are going to be repeated across some of the variations of these techniques, right? We have the connection to the database, and then we have also the action to read the ADFS configuration. When we start talking about connecting to the database, by default, the connection happens over a namepipe. And that namepipe, the format of the namepipe will change a little bit depending on the version of your server, right? And then if you're actually using a SQL server by default, you also have namepipe connections as an option, right, to connect to that locally. So there is also a way to connect actually locally to that database. And now this can happen, of course, via APIs, and this could be done by any tool that you write, right? It could be PowerShell, C#. I mean, you can do a lot just to get to the same kind of like artifacts, right? You're going to be using some APIs to connect to this somehow. Then there is, of course, if there is a connection, there needs to be some type of authentication. A user needs to log on to that SQL server, right? And then this variation talks about that once you have a connection to the database, then you can run SQL queries so that you can start accessing the ADFS configuration. And this is one example of that basic SQL query, but there is different ways to do this. And threat actors are actually good at this because they kind of monitor what is the normal way that this happens, and they can probably replicate some of that, right? And when we start thinking about data sources, from a namepipe connection perspective, at that, I would say step in the operational flow of this, we have something such as sysmon logs, which monitors Namepipe connections. And then you also have application logs that would allow you to audit users logging into the SQL database and also the queries that are going to be executed to gather information from the database. Just to give you some more context, and some of this is going to be, of course, in some of the resources that we're going to be sharing at the end of the presentation. But this event is going to tell you more about Namepipe connections. You do have the context of a user, of the process that did it in the Namepipe. And one thing that you need to consider here is that there are so many different processes that are actually doing this that you will have to, based on your environment, you will have to do some type of stack counting, like trying to understand what normal is. But at the same time, think about that threat actors do the same thing, and they will try to probably be able to impersonate some of those users or processes or inject their own sessions into whatever is normal. So think about that as well when you do this. And these are just two examples of those Namepipe connections. When we talk about logging, actually logging into the database, this is one example of the event. This is going to be sent to the application logs. And this is how you actually can enable it manually. By default, only the, so you have the successful logins, and you also have the failed logins. So failed logins is usually what is enabled by default, right? And then if you want to audit those queries, you will have to actually create a servlet audit and database audit specification. And that would allow you to specifically query anyone actually reading your ADFS configuration, the settings in that table that exist in this database, right? So same thing as before, I would actually try to see how this is done. And this is one example of how this is accomplished, and this is done by tools like AD internals created by Nestori. So just kind of keep an eye on those SQL statements right there. Okay?
Okay. The next one is Dotnet Reflection. And that attack is based on the fact that, well, you have the legit command called get ADFS properties, which is returning an object that has the setting of the ADFS. But that has also hidden properties and methods which you can call using Dotnet Reflection. So basically, you ask ADFS that, hey, give me the configuration, and it will get you the configuration. So you don't need to do the access to the configuration database. And I think it was first introduced a couple of years ago in ADFS migration tool or something like that.
Yeah, I think it was 2014, 13.
Yeah. So it has been there a long time ago, but we just spotted that a year ago, something like that. But very interesting way. So when it's using the Dotnet Reflection, so you really can't see anything, right? Because that's a quite stealthy way, because ADFS is doing that. Or can you do something?
Yeah, so there are a couple of things you can do, of course, but first, important to understand what's going on, right? So similar to our previous example, in this scenario, we're not creating a new connection. We're actually using what's already established, but we're still going to query that information. And similar to what Nestori was saying, so in order to do this, we need to get the ADFS settings as a .NET object, and you can actually accomplish this by using a built-in ADFS commandlet. This will give you that ADFS settings as a .NET object, but the properties available in this object are actually public properties. So the goal is to access private properties in this .NET object. So you can accomplish that actually by trying to get a specific private property called service settings data, and then you can get the value of the .NET settings object pointing to that private property. And that's pretty much how you can get the ADFS configuration from a database. And of course, if you're using PowerShell, all this can be accomplished with PowerShell. But if that's not available, you also can explore all that information through AMSI, right, which is the anti-malware scan interface. And when you think about PowerShell, so you have to also make sure that you understand the version of PowerShell that you have in your system. So version 3+ would give you something like this event, the 800. This is a classic PowerShell log that does not have actually process information. It lacks of user information, but it could actually show you that the commandlet was executed, right? And this is kind of one example in there. 4103, it's a pipeline execution type of log available on version 5+. And this one will give you process context, so you can actually correlate that with other events. It will give you user context, so you'll know exactly who's executing this. And then you can correlate that with something else, right? You also have 4104, which is a script block logging, but you do have to enable what is called global PowerShell script block logging. By default, this actually is enabled, but only to capture events that are triggering because there is suspicious strings being passed through the PowerShell pipeline execution pipeline. If you want to capture more than that, then you need to enable the global PowerShell script log. Now, AMSI is an interface that allows applications to send data, right, to, for example, anti-malware vendors, right? And that information could be file scanning or memory scanning information, right? Content from, for example, PowerShell execution, all the way to maybe a PE file or a binary being loaded into memory, for example.
So is this like some built-in Windows feature?
Yes, it's a built-in feature, and these are some of the apps that are designed to actually send content to AMSI. This is just for reference, of course. And we're going to focus on the PowerShell one for now.
So you really don't need to buy anything extra to use that?
Nothing extra. Just,
okay.
Just if you want to do research, this is how you actually would enable it, right? So you can just use logman, start a trace, and then execute your attack, and then stop the trace, and you're going to get events. But the problem is that you won't be able to read them because the content cannot be interpreted. But thanks to researchers like Matt Graver from Red Canary, a company that shares a lot of content with the community, he put together this PowerShell script that allows you to actually parse those AMSI logs, and you will be able to get to, for example, as a basic proof of concept to all the code that was passed through, for example, PowerShell, right? Now, as I mentioned before, 4104 is a script block logging, and this is enabled by default only for warning events, okay? And this, for example, trigger on this step of our .NET Reflection technique, and that's because there is actually a lot of strings that are considered malicious, so it would actually scan the contents of whatever is passing through the PowerShell execution pipeline and then trigger. So in this case, we had properties being pulled out, the properties that were actually non-public, so that's why this event actually executed. And that's how I would approach some of that detection.
Yeah, thank you. So quite interesting that you are actually using .NET Reflection and you're still going to pull that amount of data, so that's amazing what you can do nowadays. Okay, but then we invent something else called Synchronization config. And what this does is, so this is leveraging the first option that you are using, the Windows Internet databases. So this is leveraging the same synchronization like process, if you will, or protocol that they are using. So this requires that you have like credentials that have permissions to read that configuration data. So that's usually is like the ADFS service user or then the local admin of that ADFS server. But you can do this remotely. And this is using the port 80, actually. So it's not encrypted, but the content of those messages are. So even though that's like a port 80, like HTTP, the SOAP messages are actually encrypted. But yeah, so what can we do with this one then?
Man, there's a lot to do here. There is so much information that I actually didn't even know about. So let's just dive into that thing. So following our first example, there's going to be, once again, a similar operational flow. We need to connect, as Nestori said. We're connecting to port 80. And that's because there is actually a service that is going to be used on the ADFS server that would allow us to then interact with the configuration by simply syncing, like replicating content back to us, right? And this service is called the Policy Store Transfer. It's a WCF service, which is a Windows Communication Foundation service. And in here, you can start actually the basics, right? What data, what logs will give you network connections? But at the same time, what it is that you can use to validate that those connections were actually performed so that you can interact with the specific service, right? The policy transfer service. And in this scenario, there is actually a mitigation that you can apply. So in the previous one, in the previous way to get the configuration, most of those operations actually are part of the functionality of ADFS. So technically, you can blend in. You cannot block that, right? If you compromise the ADFS service account, you simply can operate as if it was regular businesses. But in here, if you do not have other ADFS servers that are communicating with your ADFS primary server to do a synchronization job, then there is something that you can do, right? Network connection, very simple. This is just one example. And here with Sysmon and other similar telemetry, you get user context once again, process context, source, and target. But not enough into like, why is this connection even happening? 5156 from security auditing, something you can use as well. You miss the user context, but in this scenario, it doesn't matter because this connection is handled by system. So we're not expecting a different user, right? And here's when we start getting into ADFS logs. This log is actually a log that can be consumed. You can actually see it through ADFS tracing, but this is something that will also be populated in your security event log. The link at the bottom is going to be a link that will show you how to actually enable all of this. And in here, we're actually getting information about the service model, which is going to be part of the WCF, actually context. So you can see that there is some authentication happening in here in regards of the WCF service. 501 is something that you can actually correlate with the previous one so that you can then understand who the caller was that performed this operation, right? And the reason why this is important is because you might have a threat actor that might have modified maybe the rules on the ADFS database to be able to access it with a different account to maintain persistence. So then you can start tracking that type of activity. And 4624, it's something that will have to trigger because in order to interact with this service, you need to authenticate. And this one was very interesting because I did not understand why in my logs I had something such as company SVC ADFS when that was not the account that I used to set up my ADFS servers. And I didn't know what it was, to be honest, and I was just trying to read as many documents as possible. And then, and that was something that actually came from Nestori's tool.
Yes,
and
so actually, that is hard-coded in AD internal, so if you are using that tool, it's always that same name. I just wanted to make it easier for you guys to
exactly. So, yeah, but they make it hard because I had to read like for hours and figure out what's going on.
About that?
So in here, this is a plain signature. You can actually see that this 4624 event was a network connection, network logon session, but it doesn't have a source. Like we don't know where this actually came from. And if you go to AD internal source code, if you get to the section where you can test how WCF is actually used, Nestori creates its own ticket, its own TGT, and all he uses is a hash of the account, and then he simply starts creating his own ticket, and then he passes that to the service in order to communicate. So that's why we do have that specific event. So if you go back to your company or right now and you check 4624s for that name, I would be a little concerned, right? Probably he was doing consulting or somebody's using his tool. Now, this is very interesting that I did not know that existed, to be honest, because I skipped probably the documentation. But there is actually a way to enable additional WCF or services that are built with that framework in ADFS. You have to find this configuration, which is usually on the root of ADFS, which would be by default C Windows ADFS directory. Once you find this configuration, there is a section that allows you to modify it so that you can then enable additional telemetry. And this telemetry, you can start either interacting with that through the ADFS tracing, debug, analytic views in Windows Event Viewer, or you can actually use Logman to create a ETW trace, and then you can analyze it on the side offline, right? And as you can see, when I did that, then all these events started populating that were not populating when I started testing the capabilities of the service to access and synchronize information from ADFS. This is one of the first events that trigger. 121 gives you information about the connection. This is the first time that you see a network connection mapped to the service that allows the synchronization. When you were looking at Sysmon before, there is not additional context that would tell you this is exactly what happened. This would tell you that this actually happened, right? So it's something that could be consumed. It's something that you can also explore. Other events like 998 would start giving you information about the URL used to communicate with the service. You also have more 121s, but they start giving you more context, such as, for example, there was a message that was received, and there is also information about, for example, the user agent that was used to perform this type of communication, something that I had not seen in other event log. And since we were using AAD internals, which is used with PowerShell, you can find user agent PowerShell information in the logs as well. So something really cool to dive into and see what's going on, right? Then you start getting into understanding the negotiation process when you start interacting with ADFS. So this is just more information telling you how this is actually happening, all the way to telling you that this completed, and then you can start seeing, for example, that there is a message now being sent back to the user. So this is definitely a lot of good information. There is even more events. I didn't go through all of them, but these are kind of like the main ones, especially the ones that really tell you that the network connection actually was performed for that specific service. So the technique can directly be mapped to the first 121 event, for example.
Yeah, it's also good to turn that on just for getting the forensic data.
Exactly. So from a mitigations perspective, you can then, for example, use these two commands. One could be to modify a current maybe rule that you have to restrict access to this port, or you can create a rule if it's not created and you only point to your ADFS servers and also your proxies, right? I think that you were mentioning that ADFS proxies should also be part of this rule. And that concludes that one piece on the top, right? And just to go quick on this part, we were actually going through a couple of different variations, different operations executed depending on the way how we wanted to, for example, get the configuration. And then we can actually start mapping multiple data sources that will tell you that something is actually happening in this specific flow of operations. And then how you can start blocking one specific path, for example.
Okay. So now we covered how to get the different ways how you can get the configuration which contains the encrypted token signing certificate. And now we go into the key part. So how can we get the key? And the first one is, again, the Dotnet Reflection. So you need to comprise the ADFS server and then run it there. And here you just instantiate a certain .NET object and then again call the hidden private parameters, properties and methods. And you basically ask that ADFS that, hey, could you give me the key, please? And then ADFS goes there and picks that up. So it is the totally same thing that ADFS, when it starts up, it gets the key. So the network traffic is all the same, and all the access to objects on AD is same. So I bet you really can't find this out.
Yeah, so this is going to be tricky, but it kind of follows a similar pattern as the previous Dotnet Reflection, and there is a lot of .NET happening in here. So that could also be a way if you are actually collecting multiple operations, like getting methods, fields, properties that are private. That's what this all takes, like a lot of iterations. So this is probably the graph that you were expecting. So this kind of walks you through all the flow step by step, and because of the time, we can't go through all that. But the idea is to go all the way from an ADFS configuration setting as a .NET object, and then utilize existing DLLs that would expose specific assemblies and classes that you can then use to iterate to private fields, private properties to get to a private method that would allow you to enumerate keys in the ADFS server. And that key is the ADFS DKM key, right? Now, the interesting part, once again, you can use, for example, PowerShell or AMSI logs to capture all this. There are different EDRs or XDR solutions already capturing some of this information, for example, so they can actually do something about Dotnet Reflection. It's really tricky. And in this case, as I mentioned before, if you are executing this attack step by step, which could actually be done interactively, instead of doing a full script, you can actually run each command if you have a session. And then this would actually start triggering a lot of different default 4104 events. And that's because, once again, it has all these suspicious strings that are being executed just to get to the private, like non-public method that will give you the keys. And as I mentioned before, you can use something like that script that would allow you to go through and find all these strings that were executed, right? Now, the interesting part, besides the Dotnet Reflection piece, because that's just .NET that you have to find through some telemetry, is that actually there is always unintended consequences when a red teamer or threat actor or offensive security researcher in general, right, when they do something on a box, there will be things that they expect that happen and that they have control over. But there are things that they don't have control over. One of the things that they don't have control over is that when they start executing these steps where they invoke the enumeration of keys, then they start actually making a lot of LDAP connections, because they're actually going to the domain controller, retrieving the key, and then giving it to you. But locally, it looks like you're interacting with simply .NET objects locally, but there is going to be connections that are going to happen, right? So that's an unintended consequence. And you can actually start tracking this by using this event provider with Logman, and you will be able to get to this specific LDAP query that by default, ADFS service under the hood is actually executing. So for those that maybe want to replicate that and look similar, then that's the query that happens when Dotnet Reflection is used in this scenario. And that just proves it that the query that is being executed is actually trying to get to that object in Active Directory, and that's the ADFS DKM container that has an AD object that contains information about the ADFS DKM key.
Yep, okay, thank you. Yeah, so we actually tried to squeeze 60 minutes presentation to 40 minutes, so I think we need to speed up a bit. Okay, but anyways, then the remote method. So actually, you can remotely access also AD and find that container Roberto mentioned, and then find that contact object actually, which type of contact, and then there's one certain property that contains the key. So that was actually also the part of the original ADFS dump tool. So they access the configuration database, and then they, query the AD. And of course, you can do something at the
Yeah, so just to go quick on this one, since we already covered it with the previous example, there is going to be access to an object that is going to use LDAP, right, queries. There's going to be authentication of users against the domain controller. And there is going to be data that will be triggering the access attempts to those objects, right? And of course, data for user authentication as well. And you can use either ETW tracing, which a lot of EDR solutions will use on the client side. And they would also client and server, and then also some network packets if you're using some type of network data source. You can actually enable telemetry by adding an entry to the SACL of the AD object that contains this key, right? So you can actually do it by adding for example, who is reading or who is listing this property. 4662 is the event that will trigger, telling you that this actually was accessed, and there's going to be a property that is going to map directly to the thumbnail photo attribute of the object, which is where the key is going to be stored, right? And then you can actually correlate this with authentication logs, and you will be able to know exactly where the client is. If this is coming from an ADFS server, you will see the ADFS server IP. If not, you will see another computer. And then, as mentioned before, you can enable the LDAP ETW tracing to start collecting some of that information. And then this is one example of that LDAP search query.
Okay. And then the last one of this part, attack part, to get the key. So because that's stored in AD, then you can access the AD also using a thing called DC Sync, which is a protocol that domain controllers are using to synchronize data from other domain controllers. And that requires that you have some permissions to do that. So, of course, the ADFS like service account is a good one. And another one is that if you can compromise Azure AD Connect server, you can use that account that it is using to, synchronize data from on-prem AD to Azure AD. But that's a normal traffic, right? So can't do anything, right?
I mean, if this of course happens from from a non-domain controller host, then that would be kind of easy to detect. If it happens directly from a domain controller, good luck. There is not much telemetry out there. But the idea is that we want to access the object in an indirect way. So there is not a SACL that will help you here because there is not a direct access to the AD object. And we're going to, of course, start linking this information with login information. And let's go directly to the events. Oh, and there is actually mitigation. So there is now, it is becoming a thing to be able to do RPC filtering, and there are some solutions out there that are accomplishing this on your domain controller so that you can so that you can actually start restricting who can access your domain controller using the directory replication services remote protocol.
So is it kind of a firewall for RPC?
I think it is, yeah. It is viable. It definitely works. I've seen some companies using the one that I'm about to share. 4662 will show you not an access directly to the object, the key, but actually the interaction to access the what's called the domain DNS class object. And if it uses an extender right that is related to synchronizing information from the domain controller, there is when you can start saying that this could be a suspicious DC sync potential attack. And you can actually correlate this with authentication events so you understand where this is actually coming from. And as I mentioned before, there is actually RPC filtering that you can use in order to restrict who can actually use this RPC protocol or interface with the domain controller. So really good projects. J Security, Johnny Johnson from Spectre Ops actually has some really cool ideas in his repository. And that would just take us to the last, I would say, part, which this is what explains some of the variations of getting the ADFS key and some of the data that is available to explore this, and some of them to potentially build detections and also mitigate. And this is important because you need to understand at what layer you are mitigating this. And as you can see, it is at one attack path, but you cannot just mitigate the whole thing. So that's what is important to build these graphs as well.
Yeah, and actually now that we have those two ingredients, we have the configuration database, which has the encrypted certificate, and then we have the key, we can decrypt that. And just to speed up, you can detect that, because that's...
that was fast.
Yeah, because that's like a, make offline. So let's try to speed up a bit. So actually you can mitigate all these problems we have showed you by using the custom certificates, because they are stored in your computer, so you can access the configuration database and so on. And we have two options. So if the key, private key is not marked as, if that is marked as exportable, you can just go to MMC and export that. If not, then you need to use some tools, like AD internals or Mimikatz or whatever you like to use. And for that, it's a bit noisy, I would say, because it's using a DP API, or as we call it, DPAPI.
DPAPI for all of us.
So if you have a local system access, or local admin access to that system, you can be the system, and then you can do the encryption by yourselves.
Right.
So that's kind of...
so the idea here would be...
wrap up these couple of slides.
To understand that you can actually mitigate this by executing the thing at the bottom, and you can mitigate the thing at the bottom by using things such as HSM when you're actually using a custom certificate. So there are ways to actually do this type of preventions. And just as an additional, I would say, information, there is actually solutions that would provide detections across some of this from MDE and MDI. Just think about the MDE covers client-side things, and MDI, Defender for Identity, will cover things at the server side. So that's something that we have worked together for a couple of years, 2 years already, to try to create detections around this. And of course, just remember that this is just part of an attack sequence. This is not the whole sequence, right? So there are different opportunities. And if they succeed at this, they can get a token, right? They can get a SAML token. You can actually enable MFA, right? People might say enable MFA, but they can actually add MFA to the token. But then there is other things that you can do, such as, for example, rejecting the MFA claim that came from the IDP. And that's something that Azure AD is providing. So something that you can read about and will block the next step.
Yeah, so this is a slide actually. So how to mitigate? So first of all, treat all ADFS servers as a tier 0, so you need to protect them as well as you protect your domain controllers. Second, configure that setting that Roberto mentioned, that you reject all the MFA claims coming from federated identity providers. And if you are using ADFS managed certificates, you need to block that port 80. And also treat SQL Server if you are using that as a tier 0. And if you are using custom certificates, block 840 again, and then use HSM or hardware security model. And that's actually the safest way to do that, so please do that.
Yes, yes.
So it's a little bit burden of management, but yeah.
Sure.
And then takeaways, so there's going to be a link to GitHub page where the slides and all the other material are, and we have links for tools like AD internals and ADFS dump. There's no link for Mimikatz because if you can't find it, you are in the wrong business.
Sounds good. Hey, thank you very much, everyone. Appreciate it. Thank you. And I guess we have no time for questions.
Yeah,
so.
no time for questions, but you can, ask from us.
Cool.